Hello class, and welcome to lesson 1.5, the inverse function. Today we're going to take a look at some warm-ups, which is homework questions. Now, just due to the length of time it takes to write these out, I just kept the answers out here, but I'll explain them. So taking a look at some of the questions from 9 and 16, if you want to pull out your homework, we'll double check that. So 9a, f at x equals negative 3x plus 8. Ladies and gentlemen, that's a linear function. It has a slope. So we know that domain is x belongs to a set of real numbers, and range is that y belongs to a set of real numbers. Looking at b, ladies and gentlemen, you should have noticed that this is a quadratic relation, so it's a parabola when we graph it. Your vertex, ladies and gentlemen, is negative 3 and 4. Okay, so you can plot that. And then taking a look at your direction of opening, guys, you know that it's down. Okay, so here's your relation here. So as we go from left to right, there's no restrictions. So domain is that x belongs to a set of real numbers, and range is y belongs to a set of real numbers such that, where's the maximum on y? It has to be less than or equal to 4. Okay, and again, that appears in your second part of your optimal value, which is the second coordinate of your ordered pair of your vertex. Okay, taking a look at h, ladies and gentlemen, again, that's a square root function. If you're wondering what it would look like this. Okay, and looking under the square root, remember that it can't be equal to 0, so you solve for that. Okay, and because it can't be equal to 0, that gives you the range restriction, and when you solve that, it tells you that x has to be greater than or equal to 1. We will make that more complex after we deal with our parent functions, which I believe is our next lesson. Okay, so we'll be dealing with that in more detail later. All right, D, ladies and gentlemen, is a quadratic. Okay, we know our vertex is 2, negative 5. Direction of opening tells us A is positive, so it opens up. Okay, so you graph 2, negative 5. Just think about it, can be anything along this line. Okay, and so as you take a look at your domain and range, it's x belongs to a set of real numbers, and y belongs to a set of real numbers such that, in this case, this is a minimum, so it has to be either negative 5 or greater. So y is greater than or equal to negative 5. Okay, looking at E, ladies and gentlemen, Q at X, it's a linear relation. So again, you've got a slope, so domain and range both belong to a set of real numbers. No restrictions there. All right, taking a look at F, I believe by accident I wrote down an S, and it should be an X, am I right? Okay, so let me just fix that. Okay, so r at x, and again, it's a square root function. Now, ladies and gentlemen, this is a tricky one. I want to stop and make sure we know this. This is written funny under the square root. What you notice, folks, is that the x is negative. And when you've got a negative value in your inequality, i.e., when you divide by a negative, you have to flip the inequality sign. So whenever you divide or multiply by an inequality, you have to flip the value. So we should probably write that in. When multiplying or dividing by a negative, flip the inequality. Okay, that was maybe one that would have tricked you. Okay, and we're going to get into that, ladies and gentlemen, when we do a transformation where instead of it reflecting the x-axis, it's going to reflect the y-axis, which should be lots of fun. Okay, where are we? Oops, sorry. All right, 16. Okay, so 16, ladies and gentlemen, asks for an example of I don't have my textbook with me. So hopefully this makes sense, ladies and gentlemen, as long as I guess it gives you, it says to draw a graph, I'm assuming based on the restrictions. So it says, I'm assuming that y has to be less than or equal to 2. So you could do anywhere along there. And I'm assuming B part tells you that there is a restriction on x where it has to be greater than or equal to negative 4. Okay? All right, let's get with today's lesson, ladies and gentlemen. 1.5, the inverse of the function. The inverse of a function is the reverse of the original. And that's what we're going to be using. We're going to do reverse operations in reverse order today. Kind of funny stuff, which is really cool. Okay, we could graph the cost of bulk candy as a function of mass. The inverse would be the mass as a function of the cost. Okay, this means that point xy becomes point yx. So basically, to do the inverse, switch x and y values. All right. All right, graph the inverse of each function. Well, first of all, ladies and gentlemen, just remember, if you take a look at some of these, the first smiley I'll do right here, what ordered pair do we have for that one? We know that that is 1 and -1. If we switch x and y, it's going to become -1 and 1, so it's going to become here. So that's going to become -1 and 1. Okay. If I do another point, for example, if I do 4, 1, the inverse of that, if I do the inverse, that's going to become 1 and 4. And if you're wondering about the nomenclature, say I label that B, this is going to be B inverse, or B prime. If I go back and label the first one A, this is going to be A prime. Okay, or inverse of A. Okay, let's do a couple more here. How about I label this one on the bottom here C, and C is at 5 and -5. Okay, so do the opposite. You're going to be at -5 and 5, so this is going to be C prime. And the last one I'll do is D. So if D is -2, -5, it's going to become what? -5, -2. So that's going to be D prime, which is -5, -2. And I apologize, I forgot to put the ordered pair for C down, which is -5 and 5. What you should notice, ladies and gentlemen, is with all of these, ladies and gentlemen, it creates a mirror image about y equals x. Okay? So notice there's a mirror image there. That's a good thing when you're plotting points. It's easy to see. Now, we can graph the function and do the inverse of it as well. All right. So what do we know, first of all, ladies and gentlemen? We know that based on this equation, if you want to take a look at it, if you want to find the vertex, you got to be careful because it's really y equals x minus 0 squared minus 3 when you think about it. So our vertex here, guys, is 0 and -3. Okay, so let's plot that. Okay, so we've got 0, -3. Looking at our step pattern, a equals 1, so it's going to be 1, 3, 5. You good with that? Okay, so go over 1, up 1, over 1, up 3, 1, 2, 3, and over 1, up 5, 1, 2, 3, 4, 5. Do the same on the other side, over 1, up 1, over 1, up 3, and over 1, up 5. So this is the actual function. Okay, now to do the inverse, we're going to flip things around. Okay, so just let me back this up for a second. This is the vertex 0, -3. If I want to find the vertex of my inverse, you got to flip them around. So my vertex that's prime is going to be -3 and 0. And the funny thing is, instead of going over 1, up 1, you're going to go across. So over 1, up 1, over 1, up 3, over 1, up 5, because you're doing it the opposite direction. 1, 2, 3, 4, 5. Likewise, you go down 1, over 1, down 1, over 3, 1, 2, 3, down 1, over 5. Right there. Cool, eh? Pretty neat. So this is the inverse. So y inverse. Okay. Now we don't always have to graph it. We're going to learn two methods down below. where when we're given the equation, you don't have to graph it in order to find it, because sometimes this can be quite complicated. The one thing I want to point out here, folks, is that although the quadratic that we started with, okay, so although the quadratic that we started with was a function, when we do the inverse, what do we notice? That it is not a function. Why? Because it would not pass the vertical line test. So the inverse of a quadratic will not be a function. All right. When you are given an equation, there are two methods to determine the inverse. Okay? So here's method one. What we're going to do is we're going to find the inverse by reversing the operations and the order. Okay? So based on this expression, let's start with x. Okay. Now what do we have to do to x? So work inside here. Start here. The first thing we have to do is what? Subtract 3. Then what do we have to do? Take that whole expression and multiply it by 2. Okay, after we multiply it by 2, we have to do what? Add 1. We've got our expression. Now what we're going to do, folks, is we're going to do the reverse and opposite sign, opposite operations. So reverse order and opposite operations. Sorry, brain fart there. Operations. Okay, so let's do this. So to do the inverse, we will start with x. There's my short form for width. Start with x. Okay, instead of adding 1, what are we going to do? Subtract 1. So we start from the back and do the opposite. Okay, so subtract 1. Then instead of multiplying by 2, we are going to what? Divide by 2. Okay, and then after we divide by 2, instead of subtracting 3, we're oopsie, back the track up. Sorry. Here's a case, guys, where I made a mistake. I forgot to put square in here, so I apologize. We can fix this up. So I forgot to put square in here. Sorry, my fault. I know, live video, I can't erase it and say, haha, I didn't make a mistake. Sorry, let's back that up. Subtract 3, square it. My fault. Multiply by 2. Then add 1. Sorry if I got you off there. Okay, now we're back on track. So we have to take a look at doing the opposite operation. So we're going to subtract 1. Then we're going to divide by 2. Opposite of squaring is what? Square root. Don't forget plus or minus when you do the square root. Okay, and after the square root, instead of subtracting 3, you're going to add 3. And you say, okay, great, Ms. R, that's awesome. But you just have to do the equation now. So in a separate spot, make sure you got enough room. Start with x and watch how we do this. Start with x. Then what I have to do? I then have to what? Subtract 1. Then I have to take that and divide by 2. Then I have to take the square root of this. Okay? And then I have to do what? Add 3, and that becomes your inverse function. Okay? All right, let's try another example here. Okay, so let's work with the original steps. Okay, taking a look at, we're going to start with x. Okay, what do we have to do here? First thing we have to do is multiply by what? Sorry, my spelling is off today. So we're going to multiply by -3/5. And then what do we have to do? Add 3. To do your inverse, switch it up. We're going to start with x. Okay, then what do we do? Then we're going to what? Subtract 3, and then instead of multiplying, you're going to divide by negative 3 over 5. Okay? So what does that look like? Start with x. Okay? Subtract 3, and then divide by negative 3/5. We got to do something here because it's a fraction divided by a fraction. So it's going to be x minus 3 times, flip that fraction. Okay? And it's really over 1 if you're worried about that. So what do we end up with here, ladies and gentlemen? We end up with negative 5 times x minus 3 all over 3. Okay, and if you want to simplify that out, negative 5 plus 15 over 3. And don't forget to put in f at inverse x. And I always put that in at the end because I don't know how much space I'm going to need. Okay? All right. Okay, I would also accept here if you had it, if you broke it down and went like this as well. Okay, so I'll accept any of those 3 answers. Depends on how far you simplified it out. All right, that's the first method, taking the operations, doing reverse order with the opposite operations. Okay, the second one, which I find is the most common and easiest, is interchanging the variables and then solving for y. So first of all, just remember that f at x is really y, if you just take it out of function notation. So y equals negative 2x plus 5. Okay, and your method is to switch. So switch x and y. So step 1, I guess, let f at x equal y. Step 2 is to switch x and y. So let's do that. So that's going to be x and y, and I'll put the other in regular color. Okay, and then your third step is to what? Solve for y. Okay, and don't forget to use function notation when you're done. All right, so to get y by itself, okay, I'm going to bring the 2y over here, which means I've got negative x plus 5. To get y by itself, divide everything by 2. So y equals negative x over 2 plus 5 over 2. Replace that with prime. Okay, so function prime or the inverse for your proper notation. All right. Okay. Let's try one more here. Okay, see if we can do it without the steps. So the first thing, you need to replace f at x with y, switch x and y, and then solve for y. So it's going to be 3x equals 5 plus y. To get y by itself, move it to either side. So y equals 3x minus 5. So therefore, the inverse function, okay, so the inverse function equals 3x minus 5. Okay, I apologize. I think I forgot to put my negative up there. Let's make sure I got it here. Yeah, I got it there. All right. I apologize. I have to sneeze. All right. Live video. We can't stop that. All right, ladies and gentlemen. Hopefully we made it through all right. Here's today's homework, page 46, numbers 3, 5, 6, 8, 12, and give 16 a try. Have a great day, everybody. And, of course, come see me for help if you need it. Goodbye.